Hey, physics. So we need to finish up the vector notes from class. And so I'm going to write on this whiteboard here. You'll need to follow along in the notes provided to you. So we have a couple of pages left, a couple of problems that we need to use here. And I'm going to show you how to do that. So let's start off with some of these practice problems. And I want you to do these on your own. So when you are ready to check the answer, move the video forward and you can see what I got. So the first one is, after walking 11 kilometers due north from camp, a hiker then walks 8 kilometers due east. So I need you to check that yourself. And we should find, right, we're going to walk 11 kilometers due north. So here's our 11 kilometers. And we have 8 kilometers due east, something pretty close to the same length, 8 kilometers. Okay, so we're going to draw our resultant from here to here. We want to know the total distance the walker goes. Since we're talking about distance, this is simply the scalar. So we just add them up, right? 11 plus 8 gets us 19 kilometers. That's our answer for part A. For part B, we want to determine the total displacement from the starting point. So remember, displacement is not how far you've gone, but it is how far away you are from your initial starting point. So we drew our resultant here. That's going to be our displacement because displacement is a vector. So displacement here, I can write maybe something like this, is equal to the square root of 11 squared plus 8 squared. And should get us 13.6 kilometers. So that's number one. Let's try out number two. On number two, we have a plane that's flying due north at 250 miles per hour, and it's traveling across a strong wind blowing west at 50. So we want to find the plane's resultant velocity. So we're going to be doing similar things here. So we have 250 to the north, 250 km per hour. And then we have a wind pushing west at 50. So we're going to get a resultant that looks like this. So we want to find the resultant velocity. So this should be pretty quick. It's going to be the square root. Velocity is the square root of 50 squared plus 250 squared. And that should get us 255 kilometers per hour. Sweet. So notice when we are finding resultant velocity, right? So resultant tips us off that it's going to be a vector. In the previous one, we were looking at displacement. We know that's also a vector, and it says resultant vector, right? Both of these are helping us out to figure out that we're going to have to do Pythagorean theorem to find the hypotenuse of that triangle. All right, number three is a little bit tricky. So we have a boat. It heads due east at 6 meters per second and goes across a river that flows due south at 9. So we have two vectors. We have a boat is going east with 16, and the river is going south with 9. I'm giving myself a little bit more room because I'm going to have to do some more solving. So the first one we want to find out is, what is the resultant velocity of the boat? So if we want resultant velocity, we're going to draw our resultant vector. And again, that's going to be equal to the square root of 16 squared plus 9 squared, right? Using Pythagorean theorem here. I'm going to clean that up real fast because I did not draw those very well. 16 squared plus 9 squared. Cool. what do we get? We get 18.4 meters per second. That is the answer to part A. But part B, if the river is 136 meters wide, how long is it going to take the boat to reach to the other side? Notice we are solving for a time, and we are given the distance or the width of the river to be 136. So let's consider what direction we're dealing with. So our boat is heading due east at 16 meters per second, and we want to know how long is it going to take the boat to reach the other side. So this 136 is the distance that our boat is going to travel horizontally. So right, or at least on paper. So here's our river. Cool, and we know that this is 136 meters wide. We also know that we are going across the river with 16 meters per second. Remember, in two-dimensional motion, the horizontal and vertical motions are independent. So I don't even have to consider the 9 meters per second at the moment. So let's take a moment and solve this problem. You should be using the equation for time that is equal to distance over velocity because it's constant velocity. So it should be 136 divided by 16. And we should have a total time of 8.5 seconds. Part C. How far downstream is the boat when it reaches the other side of the river? So now we have a time that's associated with our whole situation. We have 8.5 seconds. And then now we're going to start including our 9 meters per second here. So using these two givens, if we want to solve for distance, again, we're going to use velocity times time, right? That common equation that we've been using in class, or at least in velocity. So it's going to be 9 times 8.5 should get us our distance. And we should get 76.5 meters. So remember again that the horizontal and vertical motions are independent. They don't interact. And so that's why we solve them in two steps. We do B first, then part C. All right. The last bit of the notes help us understand some common triangles that you'll see in math later on. And you only start to see some of this later in your algebra classes. And so I've simplified some of the math so that you are able to determine this on your own. So the first thing that we need to figure out is what are each of these sides, because they are going to help us understand it later. So the first thing is, notice the 0 with the line drawn through it. This is the angle of our triangle. Now I can make the angle smaller, right? We call this an acute angle, or we can make it bigger and we can make our angle obtuse. Okay. So this angle we call theta. It's just the Greek letter that we use to denote angle since we're running out of some symbols. Right? We've been using a lot of different symbols in class, and math uses this Greek symbol to help us out. Okay. Don't worry about the H and the O and the A. This is going to be the important piece that you need to remember. So triangles are special, and all triangles with similar angles are going to have similar ratios between the sides. So actually, let's go over these. So there's the hypotenuse. This is the side A to B, right? So this is the hypotenuse over here. The opposite side is the side that is opposite our angle. So this is the opposite side, right? Opposite of here is that side. So this is going to be the side B to C. And then the adjacent side is the side that's just right next to our theta, our angle. So this is going to be side A to C. So these are the three different sides, and this is what that weird symbol that you see in the notes is. And so this will be helpful for us as we move forward. So the first triangle that you're going to need to be familiar with is what's called the 45, 45, 90 triangle. And I'm going to try to draw this as accurately as possible. So the 45, 45, 90 triangle has two sides of equal length. And in the corner here is 45 degrees. And hopefully you should know about triangles that they should always maintain an internal angle of 180 degrees. So if the bottom left-hand corner is 90 and one side is 45, that means the other angle also has to be 45. Now, since both of the angles are 45, right, they're equal, if ratios between sides are the same, then it makes sense that both of these sides are going to be equal to themselves. So if one side is x, the other side is also going to be x. Now, if I was going to do Pythagorean theorem, right, I wanted to find this side c, well, then it would be the square root of x squared plus x squared. And we could do it a little bit more so that we would have the square root of 2x squared in here. And we could pull out our x since the square root of a squared value is just itself. So we'll find that c is equal to x square root of 2. So c is equal to the x square root of 2. So that's actually where it comes from. So this is going to be important for us. If I know this side, right, then all I have to do is multiply by the square root of 2, and I have found my hypotenuse. Now, what if I knew my side over here? Actually, let's do the practice problem. So here's our triangle, right? These are equal side lengths, right? So these are 45-degree angles. So if this is 6, then all I need to do to find my resultant side, or my hypotenuse, is to do 6 times the square root of 2. But in physics, we don't want to leave it this way. We want to actually solve it. And you should find that side to be a side length 8.5, rounded up. Now let's actually go backwards. So I want to find, I'm going to erase some things here. I want to find my side length now using this, and you're actually going to have to do a little bit of algebra here. So I know that this is equal to x times the square root of 2, and this is equal to side x. We know that the resultant is going to be, let's say it's just 10. Let's make it nice and even. So our resultant, our hypotenuse side, is equal to 10, and we want to find out what x is equal to. So if I'm going to do that, I'm going to have to do just a little bit of algebra. Notice that my x is multiplied by the square root of 2. Right? Square root of 2 is just simply a number. I could actually work that out. I think it comes out to about 1.4. But let's solve for x. So if I'm going to solve for x, I'm going to divide both sides by the square root of 2. I'm going to do the opposite of what that square root of 2 is doing, right? It's multiplying, so I'm going to do division instead. So x is going to be equal to 10 over the square root of 2, which, because we're in physics, we don't like leaving it that way, should leave us with a value of 7.07. So this is what x is equal to. So you might have the hypotenuse side, and you'll have to find the component sides. That's how you do it. You divide by the square root of 2, and you should get your side x. All right, we are on our last page of notes. We have now the 30, 60, 90 triangle. So let's draw our triangle over here. Draw it nice and big. I've drawn it pretty much to scale here. Sweet. So the smaller angle is going to be the 30. The bigger angle is going to be our 60. And of course, this is our 90 degrees. Now, we need some way of relating all of them together. The picture I found uses a. You can use x if you want, but it's just a variable. So the short side is always going to be our smallest side, and we represent that as just the a side. make that not look like a 9. Our A side, much better. And then our hypotenuse is always 2 times that. And then our median length side is going to be side length of A times the square root of 3. So again, this is simply a way to relate the sides, and these are nice, easy triangles that match up. There is another way that we could do this using sine, cosine, and tangent, but you guys haven't learned that yet, or if you have, I don't want you to focus on it. I want us to focus on the physics itself. So this is just a quick way for us to work on some of these triangles without having to do too much math. So let's try out the triangle in the picture. We see that the triangle is flipped upside down in this case. It's pretty close to what I want. And we know that this is the 30-degree side, or 30-degree angle. And we know that this side is length of 15. And we want to find our x, the short side, the side that is opposite of the 30 degrees. Notice that, right? That's our A side, right? Same thing here. We've just flipped our triangle upside down. So 15 is equal to the A times the square root of 3. Right? That's the A square root of 3 side. So if I want to find the A side, right? X is A in this case. Then all I have to do is divide by the square root of 3. Notice that this is similar to the previous triangle, right, with the square root of 2. We divide by the square root of 2. In this case, we're dividing by the square root of 3. So if that's the case, 15 divided by the square root of 3 should give us, take a moment and solve, should be 8.66. Now, what about our resultant side? What about this side? Well, if I know that the hypotenuse is always equal to 2a, then I just have to do 2 times 8.66. And you should get 17.32. So now we know all sides of our triangles just using that simple algebra and the reference triangle.